Namaskaram. In this session, we will discuss solution of non-homogeneous ordinary differential equation. The solution of last homework. Okay, today we consider second order non-homogeneous linear ODE. This is the general form of second order non-homogeneous linear ODE with the constant coefficients. Okay, here P and Q are numbers. That's why we denote A and B. Okay, anyway, this is the general form of the ODE. Y double dash x plus A times y dash of x plus B times y of x equal to R of x. This A and B are numbers and R of x is any function of x. Okay, so the general solution of non-homogeneous ODE like this is a solution of the form y of x is equal to yh of x plus yp of x. So our general solution is sum of two functions yh and yp, and this yh is called complementary function and yp is called particular integral. Okay, I'll explain what is yh and yp. And yh is nothing, it is the general solution of corresponding homogeneous equation. That means here the right hand side is 0. We choose R of x, we choose right hand side as 0, then we get a new differential equation that is homogeneous, and its general solution is called complementary function and denoted by yh. And similarly yp, what is yp? Yp is nothing, it is any solution of given ODE. Given ODE means given non-homogeneous ODE. Okay, the ordinary differential equation has infinitely many solutions, but any one of the solution of this ODE is called particular integral, and it is denoted by yp. Okay, we have an algorithm, we will see an algorithm for finding this yp. That means we have to find, first of all, we have to find any one of the solution of given ordinary differential equation. Also, we have to find the general solution of corresponding complementary function. We know how to find this, how to solve this homogeneous equation. Okay, then by taking the sum gives the general solution of given non-homogeneous ODE. General solution means set of all solutions of this ordinary differential equation. Okay, for solving non-homogeneous ODE, we will discuss two methods. Okay, in this course, we will discuss two methods. One is method of undetermined coefficients, other is method of variation of parameters. Okay, and for method of undetermined coefficients, we have an algorithm. We will see step by step algorithm, and this method is applicable only for special type of R of x's. We have 4 type of R of x. If R of x is in that form, then only we can apply this method of undetermined coefficients. Okay, these are the 4 special cases. One is R of x of the form some e raised to gamma x, and it's a polynomial type, and cos or sine terms, and some e raised to gamma x into cos, or e raised to gamma x into sine. These are the 4 special case, 4 types of R of x. If R of x is any of these 4, not 4, 1, 2, 3, 4, 5, 6, any of 6 kind, we can use this method of undetermined coefficient. Okay. Okay, this method involves mainly 3 steps. First of all, we have to find, first of all, we have to find yh. Yh is the solution corresponding to homogeneous part. Next, we have to find yp, particular integral. To find yp, we use this algorithm. Okay, so this algorithm involves mainly 2 steps. First, we choose a trial solution depending on the right hand side. If right hand side is e raised to ax, then we have one type of trial solution. If it is a polynomial, then we have one type of trial solution. Okay, that is explained in table 1. So anyway, the main step is first we have to assume a trial solution yp. Then that yp involves unknown numbers. Okay, in that yp it contains some unknown numbers. Next, we have to find these unknown numbers using this given ODE. The thing is, suppose yp is the trial solution, then we simply find yp dash and yp double dash and substitute all these things in given ODE, then equating left and right side, and try to solve for unknowns in YP. That's algorithm. Okay. So okay, next I am going to explain how to choose the trial solution. It contains mainly three rules. The first rule is, this is the main rule. If r of x is one of the functions in the first column in table 1, one of the function means any that sixth form. Okay, any one of the sixth form. Choose yp, that is our trial solution, in the same line and determine its undetermined coefficients by substituting yp and its derivative into the given ODE. You got it? The same thing. We first of all assume a trial solution, then find the derivatives of the trial solution, substitute in the given ODE, then try to solve the undetermined coefficients or unknown numbers. Okay, that's the idea. Then it has one more rule, one modified rule, that is this one. Second one is a modification rule. The modification rule states that if a term in your choice for yp happens to be a solution of the corresponding homogeneous ODE. Okay, already we have a solution of corresponding homogeneous ODE, that is our YH, complementary part. Okay, what YH. Then multiply this term by x. This term means our trial solution. Then we multiply the trial solution by x. Okay, whatever be the independent variable. Or by x square if this solution corresponds to a double root of the characteristic equation of the homogeneous ODE. Clear? So if a term in your choice for yp happens to be a solution of the corresponding homogeneous ODE, then we simply multiply by x. If that is corresponding to a double root, then we have to multiply it by x square. Okay, I will explain this rule using an example in coming slides. The last rule, sum rule. If r of x is a sum of functions in the first column of table 1, okay, that means r of x is sum of any two functions in that 6 allowed functions. Okay, then we choose yp, the sum of the functions in the corresponding lines of the second column. That's all. Or we have another simple technique that also we will see in next session. Okay. Okay, this is our table 1. If r of x is like this, some k into e raised to gamma x. Here k is a non-number and gamma is also a non-number. For example, suppose r of x is equal to some 10 e raised to minus x. So in this case, k is 10 and gamma is minus 1. Okay. Then this is the choice of trial solution. A e raised to gamma x. This a is unknown. So we have to determine this a using our method of undetermined coefficients. Okay. We don't know. At the time of this assumption, we don't know what is a. But gamma is same as this gamma. Okay. That means corresponding to this r of x, our trial solution yp is nothing, a e raised to minus x. Is it clear? And this is our second r of x, some k times x raised to n. For example, our r of x is like some 3x square. Then what is the corresponding trial solution? Yes, a naught. Its only thing is, if it is x raised to n, then we choose an nth degree polynomial. That's all. Okay. So here this is a second degree polynomial. So this become a naught plus a1x plus a2 x square. Okay, so this is the trial solution corresponding to this 3x square. And we have next one is k cos omega x or k sin omega x, any one of them. Both of this r of x has only one trial solution. This is the trial solution. For example, our suppose our in the suppose some 7 cos 2x. Suppose our r of x is like this, 7 cos 2x. Then what is the trial solution? Yp. A is unknown. A cos omega x. Omega is 2. So a cos 2x plus b sin 2x, where a and b are unknown. So we have to find this a and b using this method of undetermined coefficient. We take the derivatives and substitute in the given ODE and try to find. Okay. And we have one more case, that is this is the last case. Some k times e raised to gamma x cos omega x is a product, okay, and k times e raised to gamma x into sine omega x, any one of them, then it has only one trial solution. For example, you consider some uh, 3 e raised to 2x into sine 5x. Suppose this is our r of x. Then what is the trial solution? Then the trial solution is e raised to gamma x. That is same. So e raised to 2x into a cos omega x. So a cos 5x plus b sine 5x. So this is the trial solution. Here a and b are unknown. So we have to find this a and b using the method of undetermined coefficient. Okay. Consider the first problem. Solve y double dash plus 5y dash plus 4y equal to 10 e raised to minus 3x. Okay, it is clear that it is non-homogeneous because right hand side is non-zero. Okay, so we know that the general solution is of the form y is equal to yh plus yp. And what is yh? YH is the solution corresponding to homogeneous equation. What is the homogeneous equation? That is y double dash plus 5y dash plus 4y equal to 0. This is the homogeneous equation corresponding to this ODE. We simply choose a right hand side as 0. Okay. Its general solution is called YH or complementary function. We know how to solve it. You write the characteristic equation and solve. Okay. Here I'm not going to solve that problem because we know how to solve such non-homogeneous equations. Okay. Anyway, this is the general solution of this homogeneous equation, c1 e raised to minus x plus c2 e raised to minus 4x. Okay, next we have to find a particular integral. To find the particular integral, first we have to choose a trial solution. How to choose the trial solution? So this is our table of trial solutions, and from this table it is clear that our right hand side is 10 e raised to minus 3x. So this is in this form, some k times e raised to gamma x. So what is our trial solution? Okay, our trial solution is some a times e raised to gamma x. What is gamma? Here gamma is minus 3. So e raised to minus 3x. Okay, so this is our trial solution. Next we have to find this capital A. How to find this capital A? You take the derivative y dash and y double dash and substitute in this equation and solve. Okay. Okay, actually this is our rule 1. In this right hand side, rule 2 is not applicable because the terms in the complementary solution is not in the R of x. Okay, so rule 2, modification rule, is not applicable. So this is our YP. So to apply the undetermined coefficients, we have to find the derivatives. So this is our YP, a e raised to minus 3x. So YP dash is equal to minus 3a e raised to minus 3x. Again differentiate this YP dash, then we get YP double dash, that is 9a e raised to minus 3x. Next we have to substitute all these YP, YP dash, YP double dash in this equation because our solution should satisfy this given ODE. Okay, so this equation becomes, okay, so by substituting these derivatives, our equation become like this: yp double dash plus 5 yp dash plus 4yp equal to this one. And what is yp double dash? This is our yp double dash, so 9a e raised to minus 3x plus 5 times yp dash, that is minus 3a e raised to minus 3x plus 4 times yp, that is a e raised to minus 3x, is equal to 10 e raised to minus 3x. Okay, then comparing the left and right side. Okay, so left by taking the sum of the left side, this become minus 2a e raised to minus 3x because this is minus 50. Okay, so minus 2a e raised to minus 3x equal to 10 e raised to minus 3x. Then comparing the coefficients, so what happens? So this implies minus 2a equal to 10, and this implies a equal to minus 10 by 2, that's equal to minus y. So what is our solution? So this is our trial solution. So our solution, particular integral yp is equal to minus 5 e raised to minus 3x. Now we are ready to write the general solution. What is our general solution? The general solution y of x is equal to yh plus yp. What is yh? Yh is called a complementary function. It is the solution of homogeneous equation. This is the solution. So the general solution of given ODE is c1 e raised to minus x plus c2 e raised to minus 4x plus yp. What is yp? Yeah, that is minus 5. This is yp minus 5 e raised to minus 3x. So this is the general solution of this ordinary differential equation, non-homogeneous ODE. By choosing different values of C1 and C2, you have to find different solutions for this ODE. They are called particular solutions or particular integral. Particular integral is any solution. Okay. So particular integral is not unique. You can find another particular integral. Now we are ready to find another particular integral. How? Particular integral is the any solution of given ODE. We choose one particular values of C1 and C2, you get another particular integral. Okay, for example, if you choose C1 equal to 1 and C2 equal to 0, that give a particular integral. Another yp, let it be yp1. What is another particular integral corresponding to this choice of C1 and C2? E raised to minus x minus 5 e raised to minus 3x. This is also a particular integral. Okay. So anyway, this is the general solution. Okay, next problem. Solve this non-homogeneous ODE y double dash minus 2y dash plus y equal to 6 e raised to x. Okay. So what is actually here a the coefficient of y dash, that is a, is minus 2, and b is the coefficient of y, that is 1. Okay. And here r of x is 6 e raised to x. So how to solve? So first we have to find, we know the general solution is yh plus yp. Yh is the solution of homogeneous equation. We can easily solve this homogeneous equation. How to solve? Okay, to solve the homogeneous equation, first of all we have to write the characteristic equation. This is the characteristic equation corresponding to the homogeneous equation, y lambda square minus 2 lambda plus 1. This is nothing, lambda minus 1 whole square. So by solving we get lambda equal to 1 1. So repeated root and repeated and real. Okay, so this is the solution corresponding to repeated and real, c1 plus c2x into e raised to x. Okay, so anyway here r of x is 6 e raised to x. So how to choose our trial solution? This is the rule for choosing our trial solution. That is, okay, what is a trial what is a trial solution corresponding to this r of x? Yeah, this is r of x is of the form some k e raised to gamma x. So our trial solution is capital A e raised to gamma. Here gamma is x, gamma is 1, so e raised to x. But there is a problem, because here a factor in the homogeneous equation is e raised to x. That is in our r of x. So we have to use our modification rule. What is our modification rule? Yes, this is our modification rule. The term in your choice of yp happens to be in solution of the corresponding homogeneous ODE, then we multiply this term by x. Okay, and multiply by x square in what case? If this solution corresponds to a double root. Okay, what about our case? In our case, our solution is corresponding to a double root. Okay, so in our case, this e raised to x is corresponding to a double root. Okay, so we have to multiply this trial solution by x square. So our trial solution is, so in this problem our trial solution is a x square e raised to gamma x, and gamma is 1, so a x square e raised to x. Okay, then all the next procedure are all same as previous problem. You just find all the derivatives of yp and substitute in this equation and solve. Okay. Okay, so first of all we have to find the derivative yp dash. By using the product rule, it is very easy. This is the derivative of yp. Next we have to find yp double dash. Again we use the product rule on these two terms. So a times the product rule on the first term, we get this one, and this is 2 times product rule on x e raised to x gives like this. Okay, first function into derivative of second plus derivative of x, that is 1, into second one, that is e raised to x. Okay, then substitute all these yp dash, yp double dash on this equation. Then we get, okay, by expanding this bracket and simplify, we get ax square e raised to x plus 4ax e raised to x plus 2a e raised to x. Next we are going to substitute. Okay, then we get like this. This is our y double dash, and this is corresponding to minus 2 y dash, and this is our last term plus y, okay, equal to 6 e raised to x. Next we comparing the similar terms. So this is x square e raised to x, and another term containing x square e raised to x, and one more time x square e raised to x. And it is clear that the sum is 0 because this is minus 2a times this is a plus a times 2a. So anyway, these two sum of these three terms is 0. Okay, then next remaining term is this x e raised to x is there, and one more term containing, yeah, this also containing x e raised to x. This is minus 4a x e raised to x, this is plus 4a x e raised to x. So you can cancel these two. Okay, or similarly we cancel these three, and lastly we have only one term, that is 2a e raised to x. So this become 2a e raised to x is equal to 6 e raised to x. And you can compare the coefficients. So 2a equal to 6. So this implies a equal to by 6 by 2, that is equal to 3. So now we determine the unknown coefficient a. Okay, that's why this is called the method of undetermined coefficients. So what is our final solution? So our general solution y is yh plus yp. We have already yh is c1 plus c2 x e raised to x plus yp. What is yp? This is our yp, our trial solution, ax square e raised to x. Now a is 3. So this become 3 e raised, 3 x square e raised to x. Okay. So this is the general solution of this problem. c1 plus c2 x e raised to x plus 3x square e raised to x. Okay. Okay, this is your homework. Thank you.